Imagine that you lived in a two-dimensional universe and that you were sitting at the origin of the complex plane and just looking around. Then you could only look in two directions, either to the left or to the right, and you could only look 180 degrees in either the left or the right direction, and then you would have seen every point. Because for any point in the complex plane that we're looking at, what's happening is that there's a ray of light coming from that point and hitting us in the eye. But the thing is, no matter which direction we're looking at, we can see our own back. Because what happens is that the light bounced off our back and then it went all the way off behind us to infinity, and it went around on the double twist off Mobius strip and came back from infinity and hit us in the eye. And on its way there, it passed through that point. So we can see our own back, and when we look 180 degrees either to the left or to the right, then we've already seen every point. And then when we go from 180 degrees all the way to 360 degrees so that we're back where we started, we've seen every point twice. In order to see every point, we can either go from 0 to pi radians looking around, or we can go from 0 to minus pi radians looking around. And then once we get to either pi or minus pi, we've already seen every point, so pi and minus pi got glued together at infinity. Just like with the logarithm, how we had to divide everything into the positive real numbers and then the negative real numbers, we have to kind of do the same thing here. The way that we fixed the real line was by gluing it together with a point at infinity. So if you went to the point at infinity from the right, then you would come back all the way from the left. And then the real line became the angle in the complex plane that we were looking at. So we were able to fix the real line by using the point at infinity to glue together plus and minus infinity. And then we fixed the complex plane by taking the circle at infinity and twisting it together in a double Mobius strip and gluing everything together like that. So we just need to keep going. So imagine now that we're in three-dimensional space. And we can see our own back because now there's a sphere at infinity. And every point that we're looking at, it's going to actually be associated with a line, which is the ray of light that's coming from that point and hitting us in the eye. And the equation of a line that passes through the origin is ax plus by plus cz is equal to 0. We're going to use that equation in three variables, and then we're going to do a projection, which means that we're going to take our x, y, z coordinates, and we're going to take that z and throw it in the trash. And we're just going to keep the x, y, and that's going to be the result of doing this projection. And so all of our points in the complex plane that we fixed up, those points are actually lines passing through the origin in a three-dimensional projective space where we can see our own back. For this person who handed us this polynomial, what we're going to do is reach in our back pocket and take out this other variable z, and then we're going to fix it up for them. We're going to make the polynomial homogeneous. So we just have to take our z and go 1, 2, 3, 4, 5, just like that. We used our z to take this polynomial in one real variable and transform it into a polynomial in three real variables. So let's say that there's a point in three-dimensional space x, y, z, which is a solution of this polynomial. In other words, if we take the x, y, z for this point r and plug it in, it's going to be equal to 0, so it's a solution. So if we are standing at the origin in three-dimensional space, and we're looking at the point R, then the ray of light that's hitting us in the eye, we can just multiply R by lambda, and where lambda is any real number, and that point's going to slide back and forth, up and down along the entire ray of light. And since we can see our own back, if it goes off to infinity, it's going to like come back from the other side and hit us in the back. So we can slide the solution along the whole ray, and it's clear that if we multiply the xyz's by a lambda, we can just take that lambda and it turns into a lambda to the fifth, and then we factor it out. And so the whole reason we made the polynomial homogeneous was to do this trick. We're going to make the whole ray of light become a solution. Sort of what we did there was, remember that sphere that was intersecting with the plane from before? And then the intersection was a circle? Well, what we did kind of was, so now every ray of light that's hitting us in the eye in this 3D space is a circle, and we didn't have to cut it. But what we were able to do is we figured out how to take the whole circle and flatten it out into a straight line, and the circle is still glued together. We just have changed our perspective, and now it looks flat to us. What we're actually looking at here is the intersection of the surface of a sphere with a plane.